Hello, this is Sam, and I'm going to show you my universal comb filter object that I created for plugins. So I'll start out here with the GUI. I have a switch that lets you switch from comb to inverse comb, and then we have a comb delay time knob, a feedback knob for the comb filter, a wet knob for the comb filter, and a dry knob for both the comb and inverse comb filter modes. Let me just show you the code a little bit. What we've got here is we have an enum class called comb filter type that we use all throughout the object, and we also call back in the plugin core.cpp, and this lets you switch between comb filter and inverse comb filter using an enum enumerator class. Here's the universal comb filter parameters data structure, and it has 5 different data variables. The actual class itself is called universal comb filter, and it's derived from public I audio signal processor, which is in the fx objects .h library and .cpp library. And here's the reset function. Pretty simple. I explain the reset and the process audio sample functions in my submission write-up. It's not too complicated. There's a little bit of DSP here involving the switch, an if else statement involving that. Other than that, though, it's not too bad. And then we also have and it cannot process audio frames, which is important. Have the get parameters, the set parameters, and in terms of objects, it just has the double sample rate variable, and it has a simple delay object, which is why it has to derive from the iAudio signal processor fx objects library. And then here it is, the parameter struct again. In the .h, you can see that we call it comb, and then we have the regular reset and then an update parameters function. In the update parameters function, I'm calling the variables here, but I'm also checking to see where the switch is, and depending on the switch, then I can set the comb filter type, which will allow me to use this if else statement in my DSP. And then in the actual signal processing, it's pretty simple. You just use the process audio sample, set it to XLN, and then set that equal to an output, and I'm just having all the outputs go to that variable. I'll now show you the plugin itself. So I'll load it up. Here's the song. We're in the comb filter mode, so I'll turn up the delay a little bit, and then we won't hear it until I turn up the feedback. Now you can hear it. I have it going from 0 all the way to 500, so if I want a lot of delay, I can get that. And then here is the controls. Dry is only for the inverse, so it's not going to be used. The wet is the total amplitude of the comb filter itself, which you can see if you look in the block diagram, which I can actually pull up here. Here's the wet, and as you can see, it's the gain. Since this is an open circuit, this is controlling the total output. And I can turn on the feedback, get a lot if we turn it up, and I'll switch to inverse comb filter. And then, as you can see again, this is now open, so now the feedback knob won't have much effect at all. But I can turn up the inverse comb filter delay time. This is just the dry signal. And I'll turn up the delay again. I think it sounds best around here, to be honest. These are just kind of funny sounding. You can kind of get some cool rhythms. that is my comb filter project. Thanks for watching.